what is special to us as an industrial engineer. As an industrial engineer, you wonder why we always talk so much about systems, or we emphasize so much about systems. The reason is just that at the core of our teaching, our practicing, we are set to make sure that we eliminate waste and optimize system. And from the perspective of an industrial engineer, we always view most things, our systems, we always view everything from the system perspective, looking from the angle of their interrelationship, interrelatedness, and interconnectivity among subsystems. And as a result of that, today, we will be talking about what we call integrated work systems, a modern problem-solving approach for high performance, zero loss manufacturing industries. There is no one who doesn't want high performance in whatever he or she engages in. And of course, for manufacturing sector, especially in a very competitive world, having a highly performing system is what enhances productivity and profitability. Manufacturers are in business to make money. And of course, they don't want to lose any coin. For you to be able to maximize your money, your resources, including also your human resources, you need to actually imbibe this culture of an integrated work system that has been viewed as a problem-solving approach. And today, we have our very own alumnus who has been in this field and engaged himself in this practical way. And of course, he has practiced it, he knows it, he was taught, he has also practiced it, and he can give us the first-hand information and knowledge of what has been happening in the real practical world. And the person is engineer Oladejo Olasheni, who graduated from the department in the year 2020-2021. I want us to open our mind because engineer Oladejo Olasheni is a seasoned engineer, and I'm very sure he's very good at presentations and also trying to implement a lot of approaches that he has learned in the course of his degree. And today we'll be having this from him. But before we go into that, we want to acknowledge and welcome everyone into this series. And today we will be first welcoming our special guest of honor in the person of our mother and a friend to the department, the Vice Chancellor of Chrisland University, Abeokuta, Professor Oyedoni S. Arulogun. You are welcome, ma'am. Also, we'll be welcoming our guest of honor, Professor A.F. Adeniyi, the Director, Center for General Studies at the Premier University, the first and the best University of Ibadan. You are welcome, sir, Professor. Also, we'll be welcoming the chairman of today's lecture series, who is the former chairman, the Nigeria Society Engineer, the Oluyole branch in Ibadan, the person of Engineer Yomi Oyerinde. You are also welcome, sir. And of course, our very own head of department, Professor Victor Luashina Oladokun, the HOD of Industrial and Production Engineering. Also, we'll be welcoming all the students of the Department of Industrial and Production Engineering, the undergraduates and the graduates, all the alumni group, also the postgraduates. Also, we will be welcoming all our guests from the university, other universities, the whole of Nigeria, and the world at large. We welcome every one of you. Also, our professors who are from the faculty We welcome you all. I've seen Professor Father Ray. You are welcome, sir. He's always there with us. He is the HOD of automotive engineering in the university. Thank you very much. Now we'll go straight to the first itinerary, which is the chairperson's opening remark. I will call on Engineer Yomi Oyerinde, the former chairman, NSC Oluyole branch, to give his opening remarks. Just to quickly, before you do that, please, we will be very mindful of time in order for us to be able to go to the main event of the day, and also not to take much time of our people, our attendees. So, sir, your opening remarks, sir. Engineer Yomi.
Yeah, thank you so very much, the moderator, Dr. O.A. Adebimpe. Well, good evening, everybody. Well, on the order of protocol, I especially recognize the special guest of honor. Talking of Professor Oyedunni Arulogun, the Vice Chancellor, Chrisland University. And the guest of honor, Professor A.F. Adeni, who is the Director, Center for General Studies, the University of Ibadan. And in similar vein, I would love to recognize the guest speaker who is going to feed us with knowledge this evening. Engineer Oladejo Olasheni, Manufacturing Operation Manager for West and Central Africa of the British American Tobacco Company. And equally, I recognize our host, our dynamic and indefatigable engineer, Professor Phil Oladokun, who is the HOD Industrial and Production Engineering, and other lecturers. And having recognized the moderator earlier, other erudite scholars who are here, our dons of standing repute, our international audience, the students, the alumnus, everybody, we are all recognized. And having done that, let me put on record that this lecture series, which 48th edition we are having this evening, has been so outstanding in terms of consistency. And I am particularly delighted about this. And I think the headship of the department and the production team of the lecture series deserve our salutation. And I hereby do my behalf and those people that are here as the chairman of education. That's thank you for the job well done. But the lecture series are kind of keeping the department, to be in touch with town and to sustain this industry stroke town-down relationship. And in similar vein, it has been showcasing what industrial and production engineering is made of. And again, it's a platform that has been keeping all of us together for this while. And we just pray that it can only continue uninterrupted. So, and as much as possible, we'll also be doing our bit to make sure we support what we are doing of the alumni. Having said that, the 48th edition of the electoral lecture series of the IPA, talking of industrial and production engineering alumni lecture series, promises to be very interesting, going by the topic, and which is to be delivered by our reputable lecturer. Of course, the topic says that integrated work system, a modern problem-solving approach for high performance and zero loss manufacturing industry. That is so instructive. Because like the moderator was saying earlier, I'm a pioneer member of the professional masters of the department, and we were from industry. And what I cherish most about the whole course content of the department is that we are all out, like we have been taught and like we have improved on, to minimize loss in anything we do in our processes for the purpose of maximizing our profit. And everything combined is said to be optimization. So by the time the topic now says that it centers on zeroing losses through integrating the system. That one may now ask, I'm not the lecturer, but I'm curious now to now ask, how do we integrate the system? I know the system, when we talk of the system, then we talk of the process, the entire process, we talk of the people, then we talk of even machines. So that is what we are going to learn more about from our lecturer this evening now. Not necessarily from theoretical angle, because we have learned a lot of theory, but now from somebody who has gone to the field and practicalized the theory, and will now tell or share his experience with us, so that every like if I want to prepare amala now, it's a process, it's a manufacturing process. So it's starting from that simple example. So that's somebody who's making who's producing a roofing sheet, somebody who's producing I know that the department has garment industry and so on and so forth. Anything manufacturing process or anything process for that matter, any engineering process, how do we minimize loss for the purpose of high performance, which is talking of optimization? I can't just wait to see that we listen to this lecture, and I'm so much confident that our guest speaker, talking of Engineer Oladejo Olaseni, who is the manufacturing operation manager of that batch for the whole of West and Central Africa, will do justice to the lecture. And I think we have done a lot of mobilization among our people across the nation and beyond. So we can only now try to listen attentively for knowledge update, and so that we will enjoy the lecture and we'll do justice to all the input. By doing justice, it means that we are minimizing losses. So we don't allow anything to waste off. So I don't want to take much of our time because I'm time constrained. Constraint is part of the things we have to take up, talking of processes, to make sure that we optimize our system. So without belaboring us, I want to welcome all of us to this 48th edition of the IPA Alumni Lecture Series. And I wish all of us happy listening. As the chairman of this lecture series, I so do hereby welcome you and declare the lecture kick-started. Thank you all.
Thank you very much, sir. Engineer Yomi Oyerinde, thanks for the opening remark. We will now have the special guest of honors, Goodwill's message. Goodwill's message from our special guest of honor, Professor Oyedunni S. Arulogun, the Vice Chancellor, Chrisland University, Abeokuta. Ma, we would like to have your goodwill message, ma.
She's about joining. Maybe our best of
all right. Okay. When she joins, we'll still give her time to deliver a goodwill message. Then our guest of honor, would like to have your goodwill message while we await our special guest of honor. Guest of honor, Professor A.F. Adeniyi, the Director, General Center for General Studies, University of Ibadan. Professor A.F. Adeniyi, sir.
All right. Good evening, distinguished colleagues, ladies and gentlemen. Thank you very much, the moderator, And as has been mentioned, my name is A.F. Adeni, and I am a professor of physiotherapy from the College of Medicine, University of Ibadan. I am very happy to be here, and I recognize most sincerely the chairman of today's occasion. That's Engineer Yomi Oyerinde. Nice meeting you, sir. And in absentia, although I mean she was supposed to speak before me, my very big auntie and a very very close sister and senior colleague, the Vice Chancellor of Chrisland University, Professor Oyedunni Shola Arulogun. I recognize her. I know she will join us very soon. Let me also seize this opportunity to recognize as has been described earlier on, I concur, the indefatigable head of Industrial Production Engineering, that's Professor Victor Oladokun. I recognize you, sir. And I must also recognize the guest speaker today, an erudite alumnus of this program, Engineer Oladejo Olasheni, who someone told me someone had sent a chat to me that really I know the person that is going to be speaking today, and I knew him since he was a baby. Somebody told, and I said, "Wow, that's wonderful!" And he's a big guy today, and we thank God for his life. Engineer Olasheni, thank you very much for doing this service to your alma mater. I recognize all faculty of the department, the faculty, and of course, indeed, all distinguished ladies and gentlemen on this call. I am very happy to be here, and I must appreciate the department for inviting me to be at this program. When I was told, I was actually, I was somewhere out of the country, and I said, oh, okay. So anyway, it was online, so even if I'm not around, I will take part. For so many reasons, because that department, although as you have heard, I'm a physiotherapist, but I went through that department as an adjunct lecturer in that department because at that time I taught quite a number of modules for the Master of Engineering Management program. I think I started in 2014 or so, and I taught a number of sets. I was involved. I taught accident and emergencies management. I taught human factors engineering. I took modules under those courses, industrial economics, bioenvironmental engineering, and corporate and security hazard. I took some modules, some 4 modules, some 2 modules, some 3, and so on. And I fell in love with the program for so many reasons. Number one, it was a very good program where you had the opportunity of interacting with students, of whom most of them were actually industry members. They were already practicing, and the class was always very cordial. We were always able to speak with real life experiences. So it was very great. And I'm very happy that this program, even up to now, the alumni lecture, as we call it, 40th edition, that's very, very commendable. And it's a huge feat, I must say. And I know that the richness of the alumni of that program should also translate to great opportunities for that program. Like the the proverbial what do you call it now? The proverbial okete in Yoruba land. You know that, I'm sorry for those who don't speak Yoruba that will say that tí òkété bá dàgbà, ọyàn ọmọ ẹ̀ ló máa ń mu, àbí? I hope I'm correct. So that is what I see. With the richness of the alumni, I want to believe that this is also translating to so many opportunities for the program. One of them is what we are having today, and like you've had in the past, and several others with respect to direct funding and infrastructure improvement. I know this is all already done or is in the pipeline with serious considerations. So without wasting so much time, because I know it's a very short program, I want to thank you once again for inviting me. And once again, I haven't stayed with that program for about 3-4 years. I think I can say very well that I'm a member of that department, and because I really, really recognize and identify with it anywhere I go to. So I wish you well, and I hope this is going to continue because it's very laudable. And I hope and I pray that the department will continue to go from strength to strength. Of course, it is the same prayer that I extend to all alumni wherever they are. They are our pride, and we wish them well whatever they do. So thank you very much for having me, and congratulations and best wishes. And we hope we are going to have a very beautiful lecture from one of our very shining stars this evening. Thank you very much. Over.
Thank you, sir. Thank you, Professor A.F. Adeniyi. Just while he was presenting his goodwill message, I got the notification that we now have our special guest of honor, Professor Yeduni S. Arulogun, joined us. So I want to crave your indulgence, everyone, to welcome Professor Oyedunni Arulogun, the Vice Chancellor, Chrisland University, Abeokuta, for our goodwill message. You are welcome, ma. We would like to hear from you, ma.
Thank you very much, everyone. Let me start by apologizing that I joined late. I had to rush in so that I can attend this great meeting. Let me adopt the protocol established by my brother, Professor Fatai Adeni. It's nice to see you again after a while. Distinguished alumni, esteemed colleagues, dear students and friends of the Department of Industrial and Production Engineering. It's a pleasure and honor to join you as a special guest of honor at this 40th edition of the Alumni Online Lecture Series. And to me, it's a platform that beautifully demonstrates how academia and industry can continue to have meaningful conversation long after graduation, because we know that there's not much departments or institutions can do without their alumni. So I want to commend the Department of Industrial and Production Engineering and the Alumni Association for sustaining this initiative. I mean, 40 sessions is no joke. And you all agree with me that it is a kind of initiative that bridges, that serves as a bridge between the academia and the industry. And that is what we all look forward to. And having done this for 39 sessions, this is the 40th one. This has been done with consistency, and I want to congratulate the department for doing this. And it's an opportunity to keep learning relevant, being relevant, having fresh ideas, and making sure that our graduates are future ready. I looked at the title of today's topic, Integrated Work Systems, a modern problem-solving approach for high performance, zero loss manufacturing industries. And I told myself, I mean, it could not have been more timely because we are looking at efficiency with intelligence, we are looking at productivity with purpose, and we are looking at innovation without wastage. And my stint time as the director of University of Ibadan Center for Entrepreneurship and Innovation, I had an idea of how this topic today is very relevant to our system. And if we have an integrated work system, it reminds us that high performance is not an isolation. We all need to be connected in terms of our thinking, where people, processes, technology, culture speak the same language. And when we do this, productivity rises, excellence become repeatable. It doesn't come in as an accident, and our manufacturing industry will thrive since we are doing away with silos. And so today's lecture, to me, it's a shift from firefighting approach that we are used to having a foresight. And it does not, this kind of approach does not just fix problems, it redesigns systems so that when we design the system, we identify the problems, we fix it, then it's difficult for problems to occur suddenly. And it's engineering at its most thoughtful, where data meets discipline and innovation. So I want to also congratulate the guest lecturer of today, Engineer Oladejo Olasheni, a proud alumnus of this great department. And I tried to find out a few things about him. His professional journey exemplifies the power of strong academic foundation that he got from our great University of Ibadan. And that foundation is meeting real-world industry experience. And his story that I found reinforces an important message to the students who are on this call and young professionals that excellence is transferable, not only local, but having global impact, and it can start where we are. So to the alumni, thank you for your engagement with your department. You stand at the heart of the transformation, and your role in championing integrated systems is not just technical, but a strategic one, a national one, and one that is future facing. And to our students who are on this call, who are listening, who will be listening to today's lecture, you are our future, and you'll be seeing your future in real time through this lecture. And my wish is that this lecture will stretch your thinking and sharpen your ambition. And to the organizers, once again, thank you for proving that distance is no barrier to relevance. And as we reflect on today's insights, may we leave this meeting inspired to build systems that waste less, not only in engineering, in every area where we find ourselves in our different spheres of influence. We strive to build systems that waste less, that thinks deeper, that performs better, and that lasts longer. So congratulations on this 4th lecture series. And once again, thank you for inviting me to share in this moment of progress and promise. I can't wait to listen to this lecture. Thank you very much. God bless. Over.
Thank you, ma'am. Thank you, our special guest of honor, Professor Oyedunni S. Arulogun. Thank you very much, ma'am, for that wonderful talk and goodwill. So the next thing we have on our event is the citation of the guest speaker. So one of the classmates of the guest speaker, who is also one of the young chap in his set, of course, one of the first-class graduates of the department, is going to present the citation of the guest speaker of the day, and that is Engineer Ekun Kevin. Ekun Kevin, over to you for your presentation.
Thank you very much, everyone. So my name is Kelvin, and I'll be presenting the citation of Engineer Olasheni Oladejo. Olasheni is an accomplished industrial and production engineer with a proven track record of over 3 years in the FMCG sector. As a result-driven professional, Olasheni has established expertise in process optimization, operational efficiency, quality management, and supply chain optimization. His ability to analyze complex systems and implement innovative solutions has led to substantial improvements in productivity, cost savings, and operational resilience among 3 global multinational giants. Currently, Olasheni serves as the Manufacturing Operations Manager at British American Tobacco (BAT), overseeing the Ibadan factory operations manufacturing for 16 end markets, including the United States of America. In this role, he ensures alignment of local strategies with global manufacturing policies, driving operational excellence in BAT West and Central Africa. His responsibilities include compliance monitoring, quality assurance, and strategic initiatives to enhance factory efficiency. Before joining British American Tobacco (BAT), Olasheni held several strategic roles at Reckitt. As the SAP Solutions Architect in Reckitt, South Africa, he focused on integrating SAP warehouse management with third-party interfaces to automate processes and improve data accuracy. He also drove supply chain efficiency through the development of subcontracting models and stock building strategies via Kinaxis and SAP APO. His tenure at Reckitt Nigeria extended to brand and consumer marketing, where he successfully enhanced consumer loyalty and brand visibility for Dettol, Morton, Harpic, Jake, and Eric through data-driven campaigns. Furthermore, he worked as a finance controls analyst, where he led digital transformation initiatives to strengthen audit compliance and streamline documentation processes. Olasheni's early career was marked by his impactful contributions at Unilever Nigeria PLC, where he worked in various roles in engineering, production, and operations planning. He demonstrated expertise in applying lean manufacturing, Six Sigma, and Industry 4.0 technologies to enhance production processes. Academically, Olasheni holds a BSc in Industrial and Production Engineering from the Faculty of Technology at the University of Ibadan, where he graduated in January 2022 and earned multiple distinctions on the Dean's Honors List for outstanding academic performance. Olasheni is a dynamic professional who thrives in challenging environments, consistently delivering measurable results and driving innovations across functions. Outside of work, he enjoys watching football and working out at the gym. Thank you all, and hand it over to Ola.
All right. Thank you, Dr. Kelvin. Please let me know if I'm audible enough. All right. Sorry, please confirm everyone can hear me.
Yes,
We
you're
can hear
audible.
you.
All right. So before I get started, I would like to once again start on existing protocol, I would like to appreciate the presence of the special guest of honor, Professor Oyedunni S. Arologun, the Vice Chancellor of Christian University, Abeokuta. I would also like to appreciate the presence of the guest of honor in presence of Professor A.F. Adeniyi, who is the director at the Center for General Studies, University of Ibadan, and also to the chairman, Engineer Yomi Oyenride, the former chairman at NSC Oluyole. And to my lecturer, who is our host for today, Professor V.O. Oladokun. Once again, I want to thank the department for this amazing opportunity to be able to come here and deliver the 40th IPAA lecture by my own self. And once again, our discussion topic today will be centered around integrated work system, which is a modern problem-solving approach for high-performance, zero-loss manufacturing industry. And this presentation will be delivered by my humble self, and then we will get started in the next slide. All right. So for our table of content for today, we'll be considering the introduction, where I'll once again, in short, be introducing my humble self, my journey through the years across the departments, and also my professional journey so far. And then we'll be going deep dive into what I mean by integrated work system. And then we'll also touch base on the evolution and structure of integrated work system. Then we'll talk about the unified problem solving. And finally, we'll look at industry-specific case studies. All right, just to recap on what the citation reader has read so far in person of Ekun Kelvin, I had my first degree at the University of Ibadan at Department of Industrial and Production Engineering, and I've had notably 3 work experiences so far, where I started my career at Unilever Nigeria before I proceeded to Reckitt, and finally at British American Tobacco. My core values include my passion to win, stronger together, and empowered through trust, where I lead a number of teams to achieve common objectives. For my hobbies, football, bird watching, and strolling. In the next slide, we'll be looking at my journey through the years, because a lot of my lecturers can actually testify to it. These are actually my pictures right from 100 level then up till present day. And these are all strategic locations in UI, and which most of us are familiar with. And on the left, I have the 3 industries I worked across. First at Unilever, then at Reckitt, and currently at British American Tobacco. All right, so this has been my professional journey all through the years, and this picture on the slides are my first day at each job. So on the left is when I first resumed at Unilever, where I happened to be the manufacturing operations engineer before I moved to the role of a continuous improvement engineer, and finally the manufacturing operations planner before I moved to Reckitt, where I started out as a finance control analyst. Then I moved into consumer marketing before finally moving to Reckitt South Africa, where I was the SAP solution architect in charge of logistics execution, embellishment, and planning. And currently at British American Tobacco, I'm on my second role. I got into BAT as the quality improvement and compliance manager before transitioning to core manufacturing, where I am currently the manufacturing operations manager. So these are my professional journeys through the years. So the main event of today, which is to consider the integrated work system, or in short, what we call IWS. In the next slide, we'll be talking about different definition of IWS, the key aim, and why should we prioritize IWS over other manufacturing strategies. And in summary, what is IWS in a nutshell? Just to draw similarities between industrial engineering and IWS, they are very much related. Even from the definition of IWS, you'll be seeing a lot of industrial concepts in it. And the same way in industrial engineering, where we try to minimize waste and maximize profits. Those are the core foundations of IWS. So shortly, in a while, what is meant by the integrated work system? The integrated work system is a comprehensive, standardized approach designed to improve operational efficiency, productivity, and sustainability within an organization. I really like this definition because sometimes, and with the way manufacturing industries are tending in recent times, no matter what you do, sustainability has to remain at the forefront of whatever you do. So IWS also integrates sustainability in its operating model, knowing that, okay, in the years to come, sustainability is at the forefront of anything we do. And even from the very beginning, IWS has integrated that. And what does the system emphasize on? It emphasizes on teamwork, because you need to bring in a lot of people from different functions: supply chain, quality, core manufacturing, security, maintenance, and all of that. It also emphasizes on continuous improvement, because you need to design a system that is constantly improving, a system that is self-sufficient, and a system that would always work with little or no human interaction. And then a key foundation of IWS is what? It emphasizes on the culture of ownership at all levels of manufacturing operation. And when we talk about culture of ownership, is even people at the lower level all taking that sense of ownership to drive business results. So key things, what are the aims of IWS? First is it's identify and eliminate losses, and which you would agree with me is quite fundamental in what we do in industrial engineering, which is we need to eliminate waste. And in the process of eliminating waste, you want to maximize profit. But here, IWS has tweaked this a bit. Instead of saying maximize profit, it is talking about creating a breakthrough business result, because the end goal of every business is to what? Is to make profit. So IWS has also integrated all those core industrial engineering principles, reducing waste through elimination of losses and maximizing profits by creating a breakthrough business result. Next, and very key to what we do in IWS, is that it involves 100% commitment and zero loss mindset. So we'll be looking at these two keywords: 100% employee commitment and a zero loss mindset. We'll be looking at it in detail. So next on the slide is telling us that why IWS? Why should industries prioritize IWS? First is that IWS has been proven and tested to produce better results above all other lean strategies. And when we talk about better results in core manufacturing, we have certain KPIs that we chase. We have OEE, overall equipment effectiveness. We have MTBF, mean time between failures. We have MTTR, mean time to repair. We also have waste. We have all of these key KPIs. IWS have been proven to provide better results when utilized than other manufacturing systems. And the key thing is that it unleashes the potential, the power and potential of a team, because imagine everybody across all levels working together in a model that involves the 100% participation of everyone. And then why should you encourage IWS? Because it has been proven to deliver year-on-year improvement through, going back to our definition, continuous improvement. And how do you get continuous improvement? Is through execution of core DMSs via key pillars, which we are going to demystify as the lecture goes on. So in summary, just like how we say it, what is culture? Culture is the way of life. Right here in manufacturing industries where I work, IWS is simply our culture, which means it is our way of working, whereby we integrate all functions. And I really love this excerpt from what our guest speakers have said. Like, okay, they really want to get an insight to how can you integrate a lot of systems into one, whereby we integrate in this presentation. When we say systems, we mean different functions, and they are right there. We'll still get to them: leadership, organization, education and training, loss elimination team, the safety team, the quality team. All of these are integrated into one simple framework in order to maximize what? Shareholders' return. And the maximize has been bolded because it's a key principle in industrial engineering. Whatever you do, you need to maximize profits. So in a nutshell, We'll be looking at what is IWS once again. You can also say it is an holistic way to integrate all systems and processes into a single complete framework, enabling operations to work together towards achieving a common strategic objectives to become stronger, simpler, and faster. So in other words, you want your operations to become more resilient, more self-sufficient, without zero human interaction, and IWS is the basics, is the foundation of that. So moving on, IWS talks about two things in essence, right? It talks about employees having mindset of zero loss, or what we refer to as zero loss mindset. They see a particular loss, they are interested in eliminating it. And how are these being integrated? Because every business usually have a plan. They have a clear line of sight, which is, okay, as a business, we need to identify where our top losses are. It's not enough for you to identify your top losses. You need people to actually resolve these losses, which means you need to, again, in IWS, we don't say we want to train people, because if you train people, after a while, they might forget what you've trained them on. So rather, we will say we want to build capability, because there's a clear difference between training and building capability. If you train me as a person, I might not be able to train others. But if you build that capability in me, I'll be able to, engage others and allow them to do the right thing. And in the process of building this capability, we are able to eliminate the losses. So bringing these two keywords together, which is zero loss and then 100% involvement of people, and we integrate both to deliver breakthrough results. And that is the principle of integrated work system. To recap again, very easy. Even if anybody asks you, what is IWS? Just talk about, 0 and 100. So you want to move from 0 to 100, right? So the 0 is you want to have a zero loss mindset, and then you need to involve everyone, 100% ownership, 0 to 100. And if you integrate these two, you have breakthrough business result, which is like maximizing profit. So on the next slide, we'll be looking at what is really zero loss. What does it mean? Does it mean absence of, defects? Does it mean waste are fully eliminated? What is actually zero loss in manufacturing industries that we find ourselves? So yeah, it means waste elimination. So when you say zero loss, it means you want to outrightly eliminate waste. So for the purpose of our presentation, and in most industries, waste are usually classified into 8. And we are going to go through the 8 of them, but we would spend more time talking about the most critical waste, which you might find it funny, but it's actually one that all businesses should avoid. So first is we have non-utilized talent. So let's imagine that you have people that are really, really competent, but they are not giving 100%. Again, that defeats the whole purpose of IWS, because you want an 100% participation from everyone, 100% ownership, 100% involvement. So if you have people that you are not really utilizing their talent, it's a waste. So the key principle of IWS is we want to eliminate losses. And some of these losses is on talents that you have, staff that you have. You want to fully utilize them up to their potential. Another key waste that we try to avoid is unnecessary waiting, which is maybe the time before you need to carry on the next step. So you need to totally eliminate that. So I think this is also related to method study, whereby you have to, are there activities that you can do concurrently just to make things faster? Also, transportation, unnecessary movement of products and services need to be outrightly eliminated, because once you have your manufacturing processes too cumbersome, you have a system that is not efficient. And as industrial engineers, we want our systems to be efficient. Another type of waste is excess inventory, keeping too much than is actually needed when you have products and materials that you are not using. And this would invariably increase your holding costs, because I remember then when we were still in school, we do a lot of theories. We talked about holding costs. But when you see these things in the manufacturing industry and how it actually affects what the company produces and their balance book, their balance sheet rather, you know that, this is the type of waste that needs to be avoided. Then we can talk about overproduction, which would spotlight. Then on defects. So we'll still get into defect, but we want to actively eliminate defect if possible. Then this also talked about motion, like unnecessary motion. And I know that when we were in like 200 level, we did something on motion study, tablighed and all of that. So we also want to eliminate unnecessary motion. And last is on what I call rework or extra processing. So let's say you make a particular goods and then you realize that, oh, the quality is not okay. Then you need to like rerun the product. That's like whatever resource you are going to use to rerun that product, that is like a waste because it requires extra processing. But then on the right, we have overproduction being spotlighted. So out of all these 8 wastes, the most ones that industries always try to avoid, but whereby if you tell some people, they'll be like, in real sense, overproduction is actually not waste because I mean, they overproduce, they can always, sell later. But no, overproduction is actually the most critical waste. And we are going to get into that, why overproduction is the most critical waste. Because whenever you overproduce, what does it mean? It means you are producing sooner or faster. So if you are producing sooner, let's say the end consumers requires a particular product like May, but you've already made it since January, you've overproduced. What that means is that, okay, the shelf life that should be 18 months, you've already produced in January. The consumer needs it by May. So you've invariably reduced the shelf life. Or when it means that you produce faster than required, that, oh, the customer says, oh, I will need this by so time, but you're already first in class. You've already produced it. Or you are producing in greater quantities. Let's say a customer requires that, oh, I need 50 cases of this product, but for some reasons you decided to make 55 cases, right? That is overproduction and it should be avoided. And the reason why overproduction is the most critical waste is it can prevent other essential activities from taking place. Now, imagine the effort you are going to use to produce 5 extra cases. That means certain activities that should be taken at that time would not take place. Number 2 is that it can even create more waste. I will give an instance of an industry example. Right here in British American Tobacco, we do not overproduce, especially on export SKUs. Because of the product that we deal with, we pay excise on all of these products. And the way it is structured, if Niger requires 3,000 cases of craving here in Niger, we have to produce exactly that 3,000 because customs are resident on site. As you are producing the inventory, they are monitoring it. So imagine you having to pay an extra 500 cases worth of excise because you've overproduced. So we are always very careful. So whatever the consumer does not demand, you don't produce. Also, overproduced item could end up as excess inventory or scrap. If it ends up as excess finished good inventory, it will invariably increase your holding cost. And what of the scenarios whereby you have to actively write it off the system and scrap it, it comes into more business losses, which you can also try to avoid by not overproducing. Another key reason why overproduction is avoided is that it affects core operational planning KPIs. There is something called CTS, which is conformance to schedule. If a manufacturing operation planner schedules the factory to produce 1,000 cases and you end up producing 1,005, it will affect a supply chain KPI, which is you are not adhering to schedule, or it is also affecting their overall output reliability. Key thing to note is that whatever the consumer wants should be provided OTIF, and the full meaning of OTIF is on time and in full. So don't forget, all of this is giving us insights on how we can get to a state of zero loss. And when we are talking about the next foundation of IWS, it talks about 100% ownership from employee. And we have this amazing chart here that shows that, okay, each loss is identified by all employees and they are working to eliminate the losses. Everybody is involved. And there is a principle that we use in IWS. We focus only on the critical loss. So which means there is a tool that you need to use to focus on the critical loss, and that is the Pareto, whereby you use 20% effort to get 80% result. And if you look at the use cases scenario below, this is for a cigarette manufacturing company, a consumer complaint that was received across a period of time. We noticed that loose ends or falling tips accounted 45 of the consumer complaints that we had was due to loose ends. And then 22 of the consumer complaints that we had was due to objectionable step. And 12 of the complaints that we got was as a result of missing pack. So IWS will tell you that if you want to actually eliminate losses, eliminate the highest, the top losses. So if I'm to focus on which loss should I eliminate, I will just try to either eliminate the falling tips and objectionable steps, because I know that if I eliminate that, I have eliminated 70% of my consumer complaints. And that is the basics of IWS. You focus on your top losses in something that we call the loss tree. You use your loss tree analysis. So while doing your loss tree analysis, your Pareto chart comes into place. You prioritize your efforts on the ones that will give you the maximum result. So in the next slide, we'll be talking about how IWS is a shift in culture and our way of work. Like I said, normally culture is a way of life. So imagine something that is also now your way of life, and that is IWS in essence. So what is the difference between the traditional approach and the IWS approach? We are going to get into it. For the traditional approach, you will realize that problems are always hidden. Like, oh, we need to manufacture this thing, but our machines are not running, but we just want to produce. So we are not focused on trying to eliminate losses because we are much more volume oriented. But IWS will tell you that it is fine if you have losses. The key objective is to actually eliminate the losses. So in doing that, you need to celebrate the reds, which is you celebrating even the poor results. So another thing that the traditional approach talks about is you need to focus on results. So far, we are producing products, right? We are okay. But then IWS will tell you that no, you shouldn't focus on the result, but rather you need to focus on your in-process measures. And when we talk about in-process measure, we talk about the things that you do to actually get the result. Because you might be getting the result by fluke, you might be getting the result by luck. But if for any reason you focus on your in-process measures, forget the output, which is the result. So in IWS, we never focus on the output. Even if our factory is at a 40%, which is bad, we will not be concerned because we'll just go back. Have we followed all the processes? How robust our in-process measures? If we can satisfy that our in-process measures are actually good enough, we don't care about the results because we know we'll definitely bounce back because we believe strongly in IWS to get us out of whatever loophole we might find ourselves. So another thing about the traditional way of work is that it's usually driven by force. But like I said, IWS is just about self-sustaining. Sometimes I don't even turn up to work. I just correspond with my team. Okay, so far they are following the rules, the guidelines of IWS. I am fine because I know that IWS is tested and trusted, and it's something that we've iterated over time, and we've seen it work, and we know that this is how we want to operate our business. And the traditional model is all about, oh, the boss makes the decision and then it's cascaded down. But in IWS, it says it's about bottom-up decision making. You empowers your equipment owners, which are like the guys on the shop floor, to even make their own decision. And then they come back with the feedback to you. And then you as a manager, you just give them the managerial oversight. And that is how we drive performance. So again, looking at it, in essence, IWS is just a way of shifting our mindset. So instead of the traditional mindset is, oh, I want to save money as much as I want. In IWS, we don't say we want to save money. Rather, we want to eliminate losses. And then in the traditional mindset, everybody will just come to work and do their bits. But here in IWS, we've made it clear that everyone needs to have 100% involvement. Then the traditional way is like, oh, you need to create goals and objectives. Set your goals and objectives for the year. In IWS, we don't do that. We set standards because we so much believe that if the standards are there and they are followed, then we should get the end result. Because then again, we want to go from the in-process measure to the output measures, and never because, oh, we want to just celebrate that, oh, today we did a 60% OEE. And lastly, like I said earlier, the traditional mindset is that they want to train their employees. In IWS, we don't train. We create and we build capabilities. So on the next slide, we'll just try to rush through it. It's all about IWS evolution. When did IWS start? How did it even come into place? Like I said, IWS is not, it didn't just come. It's as a result of different iteration of different manufacturing processes that have also been tested to be okay. So yeah, IWS is a way of working using manufacturing operation. It aims to identify and eliminate losses. But IWS alone didn't just come out of the blue. It started in 1969 as what we called high performance work system. The synopsis of our lecture here is that, okay, key things, high performance manufacturing operation, but then IWS goes beyond high performance alone. So from high performance work system, it's migrated to what we call total quality. Then it moved to process control. Then they call it reliability engineering. Reliability engineering. We want our system to be reliable. We don't want our MTBF to be good. I mean, time to between failures. We want it to be at least 30 minutes, which means your equipment fails every 30 minutes. We want our MTTR to be as low as possible. We want to do a lot of things, but IWS is way beyond that. Then it's evolved into OEM and TPM. Then later it moves to supply chain initiative. Then it moves to what a particular word that I like to use, end-to-end optimization, just like industrial engineering optimization. That sounds better. Then it moves to the Toyota system, but we don't have time to take all of these things. But then in 2015, something interesting happened. The RTT DMS was built, and that is one of the core principles of IWS. And when I say RTT, it means run to target. And as a manufacturing industry, what you want to do is you want to run to certain targets. Let's say you have a target of about 80% OEE. You need to run to that target. How are you going to do it? IWS. How do you implement the IWS? We'll get to it. Then from RTT DMSs, we see that we have some pillar setup we will still get into. We have sustainability and ESG agenda, because I mentioned in my first definition of IWS, how industry are transforming to self-sustainable solutions because of the environment and all of that. And then finally, Industry 4.0. So IWS is not a stagnant innovation. It's something that keeps evolving over the years. So in the next slide, we'll be considering phases of IWS. When they say phases of IWS, what do they mean? I will show you where most manufacturing industries are and where they should be if they decide to implement IWS. So for the IWS phase progression, any industry that does not use IWS, they are basically on phase 0, which is like the non-IWS factories, which means probably they have their own manufacturing system and all. But if you want to really, really get into a place whereby you want 0 loss and 100% ownership, then you need to trigger your IWS. And the phase 1 of every IWS is the foundation stage, or something I love to tell my team is that we need to restore the equipment to base condition. Because then again, we don't want to improve for now, but at the very least, can we restore this equipment to how the OEM install them? We are not trying to improve the OEE of the equipment. We just want to take it back to whether the design phase or the commission stage. We are not innovating as at this point. First of all, phase 1 is talked about the foundation. Phase 2 takes it further to operational stability. Phase 3 talks about the end-to-end stability, and phase 4, which is for highly agile factories. And then this is, in a nutshell, the IWS. So key thing for phase 1. So we'll focus more on phase 1 for the concept of our discussion today, which is you need to stop the stops. So phase 1 has to do with improving the reliability of your equipment, which means improvement in your mean time between failures. You need to focus on manufacturing. You need to restore the equipment to base condition. And how do you do this thing? Very simple. 2 key things: 0 loss mindset and 100% ownership from anyone. So in the next slide, we'll be talking on the pillar structure of IWS. So when they say pillar in IWS, what does that mean? I will say pillar as quite essential in IWS, because that is how IWS achieve breakthrough business result through a structured approach. And we'll get right into it. So once we say IWS structure, what do we mean? We mean we want to get breakthrough results through a structured approach. And how do we get that? Through 10 pillars. And like I said, IWS is the integration of coming together of different functions in your industry. If there is anyone that wants to mention any department in their industry, this department will be, if it is not directly here, we'll be able to link it. The LDR here means leadership. This is like, let's say the operations director, the factory manager, they are like the leadership team, right? And this organization talks about the principles of high-performing organization. This is usually where you have the HR team, where they make sure that, okay, for everyone to be fully involved, they need to have better welfare. So this is more related to HR team. E&T is the education and training. This is the team that are responsible for developing capabilities in people. Oh, I realize that I have a knowledge gap in this process. The E&T team will come, they will train you so that you can also learn, you can do, you can act. When there's LE talks about loss elimination, which we'll be spotlighting because it's also very related to industrial engineering. EHS is safety, environment, health, and safety, because any manufacturing system that is not safe is just a ticking time bomb. So EHS is also a core pillar of IWS. AM means autonomous maintenance. Would also have a spotlight on this because it's also basics of industrial engineering. And then we have the preventive maintenance. We have the initiative. IM is initiative management. So let's say you have new cost saving project, you have new innovations, and also it's innovative management. And then finally, second to the last is on quality, which has to do with goods, producing the right quality product that the consumer enjoy. And lastly is the supply chain, which is the supply network. So think of it. If you belong to any department, all of this can be integrated. So if you say, oh, but I'm in security, I'm part of the security team, how does IWS concern me? It's funny because the security team falls under organization, because you have to organize, you need to protect even the business perspective, the business goal, because of external aggression. And if you say, oh, but I'm in legal team, how do I fall into this? Maybe for some reasons, the company is fighting some certain legislation because the quality team didn't do their job. Legal can move in with quality and say, oh, there were consumer complaints and we've been sued that we make products that needs to be recalled. So everybody can be fully integrated into the system to deliver one common goal. So on the next slide, don't forget, we are considering the pillars. So we will now talk about it in a nutshell. The integrated work system are key enabler of one operation, one team, one goal, one objective, which is what? Zero loss. And then via what? 100% ownership. And also to develop one standard way of working. The good thing about IWS is that we develop just a single standard, because we want our system to be self-sufficient. If I'm not at work, the factory should be able to run without me, because again, there is a standard in place that needs to be followed. Are the DMSs being executed rightly? If the answer is yes, then we should get the result. Then don't forget, key thing is on zero loss. And also you need to be able to learn, do, and teach others, build capabilities for yourself and for others. And finally, on 100% ownership. So we'll look at how all these pillars are integrated. And don't forget, the basic foundation, like I said, is what? Zero loss and 100% commitment. And those are the principles of a high-performing organization, which takes us to the topic of our discussion today. And these are all the pillars are integrated to make sure that your consumers are satisfied, you are delivering shareholders return, and the society is happy with you because you are turning out sustainable practices, and also your employees are fully committed and fully involved. So a brief intro on how the pillars are integrated, or just to give a summary of, oh, okay, what does leadership talks about? What does PM focuses on? What does loss elimination focuses on? E&T, this is everything, but because of our time, we would not be able to go into that because we just spotlight two. And the first one is on AM pillar. So AM means autonomous maintenance. And from the word autonomous, you want certain part of your team to be able to take initiative on their own. And usually they are like the people on what I call the front line, which are like the equipment owners, which are like what other industry would call operator. In IWS, we do not call people that operate the equipment, we don't call them operators. Rather, we call them equipment owners, because we want them to have a say in the equipment. They are owners. They need to take ownership. So we don't call them operators, or rather we call them equipment owners. So the purpose of AM is to empower the what? Operator to own the equipment and reduce dependency on the maintenance person. Imagine you have a system whereby before your operators or your equipment owner would even call for support, he has already done 90% of the job. And all you just come to do is to give a managerial oversight. That is what IWS is all about. That is what the AM pillar is trying to do. And you want your team to operate at zero defect without the outside intervention of anybody. And how do you do that? You need to develop highly skilled production technician and establish proper equipment condition. So what are the key DMSs to make this thing to happen in autonomous maintenance? I know a lot of our industries, when we talk autonomous maintenance, we talk about CIL, or what some people will call CLIT as well. Clean, inspect, and lubricate. We also talk about the center line. The center line is like, oh, you have visuals in place, like, okay, this is the certain standard. For this gauge, it needs to be operated as fiber. We've seen that at fiber, the machine operates well. There is no reason this air supply goes below fiber or above. This is a center line. And the very important thing is on defect handling, because you want your operators to even be the one to tell you that, oh, this machine, I can see a defect. This thing is supposed to operate like this. It's not operating like this. And next is on the LE pillar, which is also a core industrial engineering, related to industrial engineering, is on loss elimination. And the loss elimination pillar, what it does is that it provides key tools for you to resolve losses, make choices, and also set directions. And what are the key DMSs? You have some of these that we are going to look into: the unified problem solving, the initial problem solving. We won't consider the wasted DMS, which is also critical to industrial engineering because you need to reduce waste. WPI is work process improvement, which is also a key thing in industrial engineering. And surprisingly, and not surprising to me, we also have VSM, which is value stream mapping, which is also a key thing that we learned in industrial engineering. So moving on now, we need to consider what are the key principles of IWS. We know that IWS is the way that we work. We want to identify and eliminate losses. But then again, what are the key principles? The first thing is on servant leadership, which is bottom-up decision making, empowering your team to make decisions. And another thing that we call the DDS, the daily direction setting. So basically what the DDS does is it's just a meeting. So rather than saying, oh, I have this meeting, we just call it DDS. So DDS is just like a stand-up meeting whereby we review performance, we do head checks on our DMSs, our process working, actually, in recent. So it also helps us to align our priorities. Just like I said, using the Pareto, you need to focus on your top losses. It is during your DDS that you would even know that, oh, we have a consumer complaint coming from the north. They said our product is this. Then you focus on, okay, how do we tackle this complaint? That is what your DDS is. And it's a very key thing, daily direction setting. This meeting happens twice a day. Depending on the department, it starts around like 8:30 till 9:30. You have like a 1 hour meeting. And then the follow-up DDS comes by like 4:30. Whereby, okay, the actions that we said we were going to take in the morning, have we actually executed them? And what is the progress so far? The next is what we call the DMSs, which are like a step-by-step process to either maintain or improve results. Don't forget, for phase one, I've said that we do not want to improve. We just want to restore the equipment to base condition, which is more or less that you want to maintain the results and develop standards. Exactly. And that is why standard development is also a key thing under the DMS system. So next thing is on learn, do, teach, because you want your people in the industry to also just like how we are having this session where I am taking us on IWS, we want to develop more capabilities for guys to, oh, I want to teach you on this, I want you to learn this and all. And then lastly, tools supporting zero loss. So because we know that problems will always exist, we need to develop capabilities on how we want to analyze losses. We want to make our process to improve. We want to solve problems. So you need certain tools, which we will then get in what I call the practical aspects of our lecture for today. And this is where it gets interesting, where in the next couple of minutes, we'll be considering what we call unified problem solving. So I would like to ask if we can all hear me as at this point, because we are really getting to the practical aspects, and I will endure us if we can get our writing materials. This is going to be really needed. In the next 15 minutes, we'll close up the session, but we'll go into the case studies. So once again, can we all hear me?
Yes, we can hear you.
All right.
Clearly.
So we need to talk about the unified problem solving. And as the lecture series talks about, integrated work system, right? And we want to talk about a modern problem solving approach for high performance, zero loss manufacturing industry. I think we've discussed so much on zero loss. We've discussed on high performance. For you to have high performance, you need 100% ownership. you need this, you need that. But then we need to get our hands dirty, and that's where problem solving comes into place. And I can bet you that as wherever we find ourselves in whatever industries that we find ourselves, if we are able to, if you are a problem solver, you would really get things really fast. You will see that, okay, if you're at work, you get promotions faster. You are the guys that everybody coming to. And one of the basics of problem solving is what we'll be learning in the next 2 slides. So now, the first we'll be considering is, again, what are the phases of unified problem solving? Because we want an approach that is unified, that if I apply it and somebody else is apply it, it should work. The first approach is, on, like we have here, you need to understand the situation, because you cannot solve a problem unless you understand it, right? So for the concept of our lecture series today, we'll just consider understanding the situation and root cause identification. But for countermeasures, sustaining result, and standardizing, there are stuff that we can actually read of. The 90% of the job is done on understanding the situation and identifying the root cause that actually cause the problem. So the next is, what tools can I use to solve problems? What tools? Like, okay, I know I'm interested in solving problems, but how do I go about it? I want to be a problem solver. For you to understand the situation right here, these are the tools that have been tested by industries and that we use in industry to actually solve problems. Again, we are quite innovative in the industry space, and we've come to realize that all the 99% of the problem that we face wherever can either be solved by any of these tools. For you to understand the situation, the tools that you need is 6W2H. You use it to get your problem statement. You can use benchmarking. Okay, what should be the ideal situation? What am I currently seeing? What is the expectation? Benchmarking. Is and is not is an approach whereby it's okay, again, what should I see? What am I seeing? What is the standard? What am I currently executing? Pareto charts, I think we've discussed about this, is very, very key for you to identify your loss trees, your top losses, and focus. CPOC is more complex, and for the root cause, for the concept of our discussion, we'll be considering the 6W2H and the 5 Ys, and we would really, really be getting into practical problem solving in this session. So let's start with what is called the unified problem solving. Again, it is quite simple. This is just how we solve problem in IWS. Okay, there is a loss on a particular machine that is producing cigarette. How do I approach the loss? All I need to do is, okay, the UPS approach. I will just use UPS. I know by the time I start my UPS, in the next 30 minutes, I've already gotten my problem statement. And once I get my problem statement, I know what to do. So key thing for us to note here is that, how does a problem arise? A problem arises when the effect or phenomena is different from the what's expected normal situation. The good thing is that we always know the ideal condition. Oh, this machine is supposed to produce 1,000 sticks, but then it's producing 500. There is problem, right? A problem, when does a problem exist? A problem exists when there is a gap between what you expect to happen and what actually happens. Oh, there is supposed to be one stick rejection at this point, because the machine would reject so that it can see that, oh, is the cigarette okay? But then instead of rejecting one, the machine is rejecting 10. That means more waste, Abby. So what exists, a problem exists as at that point. So how then do we bring all of this together to solve a problem? And that is what the UPS talks about. So we have this amazing funnel that we come like, you can call it problem funnel. Because look at it right here. Let me try to put on my pointer, because we are now at a very interactive session. Okay. I'm trying to annotate, if I'm able to annotate and do some, sorry. Okay, so this is a large vague problem, because the real reason is, okay, think of it as a funnel. The problem is large. You don't understand. It is cumbersome, the big part of the funnel. Then by the time you start your UPS, you start narrowing down the problem up until you are at step 3, where you can see that something, problem is off. There's a switch that says problem off and problem is cancelled. You can no longer see the problem, but you are not going to get there by fluke. And these are the processes. So for the large statement, you need your loss statement. And what your loss statement talks about is, okay, we face losses every day. They can be quite vague and unclear, right? So the next thing is for you to conduct a SysW2H. You need to understand the problem. The truth is on the shop floor where the loss is occurring. You can't be at your office and say you want to solve a particular loss. You need to be there on the shop floor. The next is that you need to validate your idea. Maybe you want to do a cause and effect. Okay, I have this problem on this machine 3, but this machine 3 and machine 5, they are the same. You go to machine 5 to check what is the standard. The next thing is you need to start asking why to get to the bottom of the issue. And that's how you establish the root cause. And finally, you need to sustain the result. If you are able to, get to the root cause, you want to sustain, right? And finally, after sustaining, you need to standardize because you have other machines that are experiencing the loss, and then you want to reapply the problems there, the solutions there. Next is on how do you understand the situation? The only approach for you to understand the situation is for you to conduct an initial problem solving. Don't forget, from unified problem solving, because the problem is vague, you need something to start with, and that is initial problem solving. And how do you go about the initial problem solving? Is what we call the SysW2H. A lot of us, we are already used to this method. Oh, SysW2H, we already know that is what, where, how, but IWS structured it in a way that by the time you use the IWS way to conduct a SysW2H, you will always resolve losses. And in the next slide, we'll get into the practical of doing that. So then again, this is showing like how the interface of conducting a SysW2H looks like. So you can see on the right-hand side, we have what, where, which, when, who, to whom, how, and how much. 6W and 2H. The H are how and how much. So all of this now, before you actually conduct a SysW2H, there is something that we call preliminary check. Because the problem you are trying to solve, you might not need a SysW2H for it. But how do you know if you need a SysW2H for a problem or you don't need it? We'll get to it in the next slide. So for this, I have broken it down into 3. As you can see, here we talked about the loss definition. If you are conducting a SysW2H, before you even conduct your SysW2H, you need to gather necessary information. Okay, what loss are you currently seeing? Okay, I am seeing film unwinding jam. I am seeing loose ends in cigarette. I am seeing high ends fallout in cigarette stick. I am seeing loose pack film. That is the loss. You need to define the loss. What are you seeing, right? And then for you to know if you conduct a SysW2H, there are certain criteria, which we call the loss criteria. This problem that you want to solve, is it worth your effort? And that is why we have the criteria. For you to trigger your initial problem solving, one of these criteria needs to be fulfilled. First is a process failure. In BAT, any downtime that is more than 10 minutes, because we are time sensitive, if your machine does not run for 10 minutes, you've entered a process failure and you need to explain. So once you have a process failure, you know you need to start your problem solving. And these things can even be done by the operators or who we call the equipment owners on their own. Or sometimes you might have an undefined root cause. You are not clear on what the problem is. Another incident can trigger you to do an initial problem solving is if you have a quality issue or quality incident, or if you have a safety issue. And then the last one, which is usually one of the most critical loss criteria. If your machine stops 3 times, let's say in a 7-hour shift, you have a particular loss 3 times within a 7-hour shift. Maybe each loss can last for like 3 seconds. You need to fill your IPS. You need to start your IPS, which is your initial problem solving, because your equipment stop is greater than 3. And on the other side is, okay, you need to gather information that, oh, which team is this thing affecting and what module? Is it the maker that is making the cigarette, or is it the packing machine? So this is how you start it. So you fill all of this. In the next slide, then we continue in what I call a troubleshooting approach, right? You want to know that if this problem I want to solve, is it worth my time? Does it qualify for a SysW2H approach? So the first thing that we have is there a troubleshooting guide to help? That particular question is TSG verification. TSG means troubleshooting guide. In BAT and IWS, we've structured our way of working up to the point that we've virtually seen every possible losses on our machine. For every time a loss occurs, we document, okay, this loss occurred 3 years ago. What did we do to get out of the issue? We document. So this troubleshooting guide, after documenting, it flows into a troubleshooting guide that is available to the operators. So once they run into a particular problem, what they need to do is go and say, I am incomplete cigarette in a pack. Usually there should be 20 cigarette stick in a pack, but all of a sudden we start to see 18. Before it gets to the consumer, it will tell me that, oh, this loss, so we last experienced it 2 weeks ago, is in the troubleshooting guide. You will follow the troubleshooting guide. So the troubleshooting guide is a set of instructions that we've already made that, okay, we don't want you to even think, because just follow IWS. There is a troubleshooting guide in place, then use it. So now the next question is, after you follow the troubleshooting guide, did you resolve the loss? There can always be two answers. Yes, the troubleshooting guide has resolved the loss. Then why do you need a SysW2H again? You don't need it anymore. Loss resolved, because there is an existing standard in place already that you followed that has resolved the loss. But what of the incident that, oh, I followed the troubleshooting guide, but for some reasons, I'm unable to the next level and say that, am I operating it with a defect? Am I operating this machine with a defect? If the answer to you is yes, you need to fix your defects, then come back. I know all of us will say like, is there more time for them to quickly do this? Because it's an iterative process. Some of the losses we are very familiar with it. So sometimes we are very, very quick in execution. Oh, I've done my base condition check. I've checked my center line. My something was out of center line, right? And I need to take it back to center line. So if you check for defects and you fix all the defects and the problem still persists, and that's why the next question is the initial problem resolved? If the answer is yes, you don't need a SysW2H. If it's no, then you proceed to your SysW2H, which is you have some certain checks that you need to do, which is, oh, you need to check for center line. You need to check for, oh, have you cleaned your equipment? Is your equipment clean? Is it free of SOC, source of contamination? The material that quality are they supply to you, are the materials okay? So if all of the answers to this is yes, 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 like I've done everything I can do, but the loss is still there, then the precursor now is, okay, you've tried your best, then it's time to start a SysW2H. So then again, there are certain criteria and fulfillment that need to be made before you start a SysW2H. We just don't do a SysW2H because we are happy to do a SysW2H. We are doing a SysW2H because we are stuck on the problem and there's no way forward. And that is what brings us to the SysW2H itself. The first things that we did initially was, oh, okay, is this problem qualified to be done with a SysW2H? And then we'll then go to the practical aspect. So there is a use case that I've prepared for the concept of this class, for this lecture. There was a problem. Sorry about this, because my team, I'll just try to give us an instance. My team were stuck. So they called me that, oh, they were having this failure mode on the machine. So they called for my assistant. I didn't do anything. I didn't talk to anybody. I was on the line. I took out a writing board. And then I started the SysW2H with them on the line. And this line we've been seeing that issue on that line recurring on Packer 16. And I started the SysW2H, and that is my handwriting on a board at work. And I did this in, completed this in 15 minutes while at work. So I conducted the SysW2H because prior to conducting the SysW2H, my team was basically stuck. They've done all their base condition checks. The materials were defect-free. Everything was okay. But then they couldn't get to the root cause of the issue. And I don't have to step in, and I conducted the SysW2H. And this is a practical example. I'll try to give us concept and also be mindful of our time, just so I will keep to time. So the first question I ask is, what are my operators seeing? What are my equipment owners experiencing? I saw that they were experiencing what I call loose pack film. So when the cigarette is made, there's usually a pack film that covers it just to preserve the moisture on the cigarette pack. But then instead of it to be clean and shiny, then it's rumpled, it is loose. And obviously that kind of product cannot go to the end market because the consumers will not buy. They might think it's even fake, or they might think that I is British American Tobacco producing cigarettes of this bad quality, because the outlook will not be good. They were experiencing loose film. But this loose film didn't just occur. By the time I was with them to solve the problem, I saw that we were experiencing 3 different failure mode. Usually for a problem, you might be lucky enough to have one failure mode. A failure mode is like, gives you an insight on how the loss is, like what can you see. So I saw that what is causing that loose film? There was an unequal film fold. So the film should fold like to the side, to the left side and right side equally. But for some reason, it's unequal. Then I saw that because of that unequalness, there was a film fold back. Instead of it to fold well to the forward direction, it was folding more to the backward. And then I also now noticed that the reason for that is that the film knife is not properly cutting to. So there is a knife that should cut the film that was not cutting it. And where I started, my next W is the where. At what point of the machine? At the film downfield region, where the film is coming down, that is where the problem is. That is the transformation area that the loss is occurring. And which is talks about which brand is for Rossmann's Nigeria and when. So because it's very important you answer the when problem, because sometimes the loss you are experiencing happens at a particular point. It might be because, during startup, every time that we are changing material, that is when the loss occur. But this particular loss occurs during steady run. And who is this loss affecting? It is affecting a particular team B for that day. And to whom? Which machine itself is affecting machine 16. Then I started how. Sometimes you might conduct a 6W28 and you might not be clear with how the loss is occurring. So the how tries to establish how is the loss occurring. So you need to ask yourself, like I said, you can only solve a problem by being on the shop floor. So I was with them that day and I saw that, okay, the sequence of operation that talks about how the film is passed from the film downfield units to the turret, that is where the problem is. And that is why I said, okay, during the film transfers from the film downfield to turret mouthpiece, there is excess wrap at the lower part of the pocket, causing unequal film wrap around the packet rather. The unequal film wrap then causes a foldback during packet movement from turret mouthpiece to long C-meter. As a result of this, the corresponding loose film causes frequent CT brush open, first CV elevator jam, and stack elevator jam. So what I did was, I have not solved the problem. I have only described how the problem is occurring. Then how much tries to establish frequency. Sometimes you might experience a loss once every 30 minutes. Sometimes if I think that solving that particular loss at that time would impact our manufacturing process, I might ask them, how much are you experiencing? They say, hey, it comes like once in 1 hour. I said, okay, you have 7 hours. You can keep running. I can manage the loss for 7 hours. I will see more of what I can do. Then after you establish all these conditions, then the next thing is that you need to write your problem statement. So to write your problem statement, it is very easy. For you to write your problem statement, you just need to combat your what, where, and how. Once you have your what can you see, where is the loss occurring, and how the loss is occurring, you've gotten your problem statement. And I wrote a focused problem statement. I explained the losses, excessive loose film wrap due to unequal film fold, and all of that. Then the next thing is that by the time you explain your problem statement, there is one thing you would always lead you to. It will always tell you which standard has failed or defects. So when I executed my problem statement, I saw that I identified 3 defects for my team. And they told me that, we've actually checked for all defects and we could not find. And by the time I did the focused problem statement, I got 3 defects. And the first one was that the film knife was out of center line pressure. And that one is called LBC, lack of base condition, is a defect. We fixed that. The film fold and overlap was out of timing. So there is a timing, a sequence of operation that should happen. It was out of timing. We set it back. Because of it was out of timing. It's a defect because it is out of base condition. We set it. And then finally, there was a missing plate in turret pocket. And I would say that was the one problem that was causing the loss, because the moment we took care of that defect, till today, Machine 16 has not experienced this failure mode and this loss. And this loss was credited to being solved by my humble self in conjunction with my technicians and my team. So next thing is, we'll then try to talk about, we've established the 6W2H, which is, let's not forget, we are not solving the problem, but rather what we are doing with the 6W2H is we are gathering information. Right here, I've not spoken about how I solved the problem, because the goal of 6W2H is not to solve the problem, but to give you enough information on the problem. Then the next slide is how we actually solved the problem, which is the root cause identification. For you to solve any problem, you need to establish the root cause. We'll be done with the lecture in 2 slides. You need to just establish the root cause. Let's recap again. We have the initial unified problem solving. From unified problem solving, you start your initial problem solving. Okay, you are not solving the problem. You just need to get the problem statement. You do your 6W2A, but don't forget, you just don't do a 6W2A. You need to, what conditions have you actually done? What base condition checks have you done before triggering a 6W2A? You just don't do a 6W2A. Once those criteria are fulfilled and the loss is not resolved, you start a 6W2A. So after you've started a 6W2A, a 6W2A does not resolve the loss, but rather it gives you more context on how to solve the loss. And for you to finally solve the loss, we need a root cause identification. So for the concept of this lecture, we have different tools for you to do your root cause. For our concept of lecture delivery today, we talked about the YY analysis, which is actually a very intuitive and a very interesting one. So I would like to say this in my concept of, when I spoke about, okay, we found a defect and all of that. So for you to solve a problem, you need to eliminate a defect, right? And the defect, we identified 3 defects in earlier slide. 2 were lack of base condition. So what we just did, we set them back to base condition, right? Then the next thing was a defect, missing plate in turret. And we will now conduct a YY analysis because we actually want to solve that missing plate in turret, a defect. We want to solve it. Then we'll conduct a YY analysis. So YY analysis has to do with you asking yourself why 5 times. Because by the time you ask yourself why 5 times, you will get to the root cause of the situation. So, and this is how it looks like on the, so first off is talk about what is the problem? Okay, missing turrets, missing plates in turrets. But why was there a missing plate in turret? Then you try to okay, why was there a missing plate? Okay, there is the turret mouthpiece is about 8. The other 7 has plate in it. That one plate that is missing, what can cause it? We are not clear. And that's what brings us to the root cause on the next slide that I'm going to show. And this is it. So there was a missing plate in turret. The reason why there was a missing plate in turret pocket was that there is supposed to be a 5 mm screw holding the turret plates, fastening it to the turret, but it was missing. That is our first why. I conducted, okay. Then I asked myself, why is a screw that should normally be there? Why is it missing? Then I said, oh, it got work loose during operation. Okay, it got work loose. Work loose is okay. A screw that is supposed to tighten something just on its own, it was loosening and it's removed. So I was like, normally, other people would just say, oh, there's a missing screw. I beg, let's bring another screw. Let's tighten it, problem solved. But no, IWS would not do that because then again, if you fasten the screw, there is 90% chance that the same thing loss would occur again because you've not established the root cause. And then I asked myself, why was there a work loose screw during operation? Then I realized that for some reason, a wrong screw type was used. So since the screw type is not compatible with the turret O, there was forced deterioration. Something that should normally last for 6 months. It's probably within 1 month. But then why was a wrong screw type? Why was it used? Normal people would have stopped by, okay, wrong screw type was used. Okay, let me get another screw and fix it, right? But then I asked myself again, why? Because I then realized that, wait, the other turret plates are a particular design. Why is this one different? Then I realized that the turret place that the screw got missing was incompatible. It was the wrong plate. And then I asked my last why. Why was there a wrong turret place? I mean, the other 7s are at the same time. Why? Then we realized that, oh, a wrong turret plate was used by the sub-assembly team. So the sub-assembly team will try to assemble some machine parts for you so that by the time you need it in production, you don't need to assemble yourself. So we just went to pick it. And then we realized that out of 8 turret plates, 7 were correct turret plate and 1 was used. But guess what? The person that fixed it, it's not like they don't know their job, but because there was no turret plate available. So what they did was that they tried to improvise, like, oh, we don't have the OEM spec, let's improvise. And that is it. So that brought me to my last why. So I now realized that, oh, the real root cause is that there was spares unavailability. I mean, most people would have thought that, oh, a 5 mm screw is missing, and then put another 5 mm screw, and the same loss will still occur. And then what did we do next? We just placed the exact order for that particular spare. And then we decided to conduct a refresher training for the sub-assembly team, letting them know that if for any reason that a particular spare is not available due to one reason or the other, you do the right escalation. At the same time, even if you are improvising, you need to test your improvisation. And that is all for our problem solving, considering the 6W2H and YY analysis. So at this point, if there are questions, we can take them now. I will just note them down and we'll pen for later. Thank you very much.
Wow, 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 wow. Thank you, Engineer Oladejo Olasheni. Well, the truth is, we are not expecting anything less, because you remember I used to say to you that time that you remember?
Yes, I remember.
Of course, you've got that good presentation skills, which some of us have noticed as your teacher while you were in the university, and you always showcase that even in the seminar series that we normally have there. And of course, we are happy that you were able to take us through this. We've learned a lot, the practical skills that you've also shown to us, and also how you have been able to implement this beyond the theoretical aspect. Thank you for this. And of course, we have learned a lot, and I don't want to take us too much, because we still have some of our guests of honor to speak. But like some people, like some of the sayings that says that together, when you stand together, you stand stronger. And also the one that says that if you want to go fast, you go alone, but if you want to go far, you go together with other people. And that is one of the key things in the IWS, talking about teamwork as well. You can't solve it alone. You have to work as a system. And of course, talking about work system, you already know that it's telling you that there is a connectivity, there is an interrelation with other aspects of the industry. And of course, you have really done justice to this. Before we will allow for questions, I want the chairperson to give his remark on this topic. I don't want to be the one recapping what you have taught or you have delivered, because the chairman will have to do that as well. So to save our time, chairperson, sir, Engineer Oyerinde.
Yeah, thank you so very much, Dr. Adebimpe, the moderator. You said wow, 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 and I just choose to repeat that. It's been a wow lecture, and mind-blowing one for that matter. The lecturer is so passionate about it. Recapping, I don't want to bore our participants, but then we have to do justice that we really understand. I mean, we really, went along with you while you are delivering the lecture, because you emphasized that IWS is a comprehensive, standardized approach that has been so designed to improve operational efficiency, productivity, and sustainability. You stress that it has to be sustainable, not that you achieve efficiency today and tomorrow that efficiency is not there within that organization. Then you emphasize teamwork, like the moderator said, and continuous training and retraining of the employees. That is very understandable, because you cannot give what you don't have. So, and that to the point that everybody in the organization will now have a culture of ownership. You won't see it as the organization's work, but everybody sees it as it's our work. So that's awesome. Taking ownership within by everybody within that organization. That's very awesome. Then you talk of IWS again. That it makes the operational process to get stronger, it makes it to become stronger, simpler, and faster. These are keywords. The operation system gets stronger, gets simpler, and gets faster, which means it enables the organization to move from 0 to 100% of involvement of all stakeholders within an organization. That is taking, that we're still talking of taking ownership of the organizational goals. The goals of the organization becomes the goals of everybody, like you have taught us. Then this one is very key to make us IWS approach. And we should realize that overproduction is a critical loss, and you justify it. You overproduce, and the shelf life is threatened. All the cost is incurred. I mean, what more explanation are we looking for? So overproduction. You know, each time we go higher, I still come simpler. That even if I go ahead and I go and sew 5 clothes within a year, and I don't need to wear more than 3, I've overproduced. I'm maintaining those extra 2 clothes might even, you know, be burdensome on me. It's losses. So I just choose to add that and go up to manufacturing to high standard now. So you talk of IWS, that is so particularly about Pareto principle, that is focusing on 20% effort to produce 80% result. Pareto principle in application under IWS industrial application. Then you went ahead to say, okay, we used to have traditional approach, vis-a-vis IWS. You did the comparison for us of the traditional manufacturing approaches or models and IWS. E.g., the decision-making process is bottom-up. Instead of, the boss has said I will do this. No, the employees are involved, and you know, identified what the problems are, and they made their suggestions part of the input into the front of of IWS. And IWS also goes beyond the high performance. It has to do with high reliability. It has to be reliable, like you have said. You stress that a lot, and you stress that with IWS, the running to target is made easier. That is, since the losses are, and everybody understands taking ownership, nobody needs to motivate another person beyond the ordinary. Before each person, you know, contributes his or our own quota. So that's why meeting target seamlessly and teamwork. You now corroborate. There is a strong correlation there. So, and you talk of 4 phases of IWS, which involves improving reliability of equipment and so on. Then you talk of pillars of IWS. So, and you say that these pillars has to do with how the IWS achieve its result. So, and you even show us the pillars structure there. Ultimately, everything is aimed to achieve high consumer satisfaction. Yes, because meeting targets and consumer satisfaction go hand in hand. The market will improve it. In the case, you talk of IWS unified problem solving UPS approach, and you talk of need to understand the structure and the root cause identification. I mean, you need to understand the situation identification, and that now, you know, was practically demonstrated in that case study that you just concluded. That made the class so. And you talk of what tools can be used. Why we're handling problem solving approach under UPS. So that's you said that to be tested and trusted too. And you give us part of which is benchmarking, but you stress that of 6W2H. Very awesome. And you say that the 6W2H itself will not solve the problem, or it will try how to not solve the problem using another approach. And that's why you talk of why, using 5 why. why is this, why is this, why is this, the boat that got loose, why did it get loose? So, and what other, so, and that other, sorry, so, and the main aim of all this remains achieving standardized high performance production by pushing losses to zero level, to zero level, to zero level. So, and then you discuss the case study. I particularly enjoyed the lecture, and I found it so practical, so interactive, and I believe that as many of us that are on this platform this evening have seriously learned. I can only implore the department and the leadership of the lecture series to please, we should try and think of having a compendium of all these lectures to be presented as position papers for the authorities across levels in our country, so that they will stop charging us of we are just having publications. We have not come up with how all these problems in the country can be solved. I think this is one of such models or compendium of models that we can use and apply to solve our national problems. When we have this kind of knowledge, then our country can boast of technological development. So, and we do know that Nigerian engineers were up to the task. Thank you so very much. I hand over back to the moderator for continuation of the program in terms of questions and answering. Asking and answering.
Thank you very much, Sam. Thank you very much, the chairman, Engineer Yerinde. What we'll have next is the goodwill message. Then after that, we take comments. Then we have questions and answer. So for the goodwill messages, I've seen one of our fathers in the department, Professor Ayodeji Oluleye. Sir, we would like you to comment and give a goodwill message. Just a few minutes, sir.
Well, yeah, thank you very much. I'd like to commend the lecturer of today for an excellent lecture. I like your enthusiasm, and I can imagine you are enjoying your work, and that is good. You've always shown that you have the potential to make great strides. I can imagine the complexity of integrating processes, technology and teams, and then you having to go through a change management system to bring up the IWS. And then, of course, the cultural shift that has to happen for these processes to be, for the system to be embedded. And then data integration and sustainability. It's a complex thing, but for you to get it all cranking as one, it's commendable. So thank you for espousing the system, and I think each and every one of us has taken away something today. I would like to also thank the chairman, Engineer Yerinde, the guest of honor, Professor Adeniyi, and then the special guest of honor, Professor Arulogun, for being with us. And I would like to also thank the HOD for heading us and managing us well. Thank you very much. It's been an enjoyable session, and God bless you.
Thank you, sir. Thank you, Professor Ayodeji Oluleye. He's our teacher, he's our father, our mentor. And of course, we can see what we have on the screen now. I think my HOD will talk more on that. Also, just if we have Professor Oyedunni Arulogun if you're still there, the Vice Chancellor, Chris
Yes, I'm
Land
still
University.
here.
Okay, ma. We'd like to just hear your remark in a few minutes.
Okay, thank you very much. I must say that I'm also really wowed by the lecture. And for me, one take-home point that I won't forget is 0 to 100%. That summarizes the entire lecture, that when we prevent loss, then we gain more. So I want to say thank you so much for this exciting lecture and wonderful, beautiful slides as well. Thank you very much. Over.
Okay, thank you, ma. Professor A.F. Adeniyi, our guest of honor. Professor Adeniyi, sir, for your remark.
Professor Adeniyi just step up to another meeting.
Sorry if we don't have Professor Adeniyi when he's back. I think he. So, Dr. Kolawole, our teacher from the department, for few remarks and comments before we now have our HOD, Professor Victor Oladokun.
Well, I just want to appreciate the guest speaker, who has been a very wonderful person, very determined, ready to accomplish whatever he's ready to do. I've seen that in him when he was about to graduate, and he has continued. I know he has a great potential to attain a very big heights. So, congratulations for the lecture. I wish you well. And I thank everybody who have come to attend this lecture. Our guests, special guest of honor, thank you, and every other one. Thank you.
All right, sir. Thank you very much, Dr. Kolawole. Professor Victor Oladokun, sir, the head of department, Industrial and Production Engineering. We would like to hear from you, your comments, your goodwill message before we give room for questions.
Okay, thank you. It has been a great lecture, and I'm proud of Olasheni Oladejo for being us proud. It's one of our fastest growing alumni, and we really appreciate you. Because of time, I will not make a lot of comments. I just want to tell us that on February 13, we have another great alumnus, engineer Ena Ofugara, who will be talking about the future of work in Nigeria, the future of work in Nigeria, preparing next generation of engineers for an era in perpetual flux. So I want to encourage us to come. Let's encourage our children to join this particular one. Engineer Ofugara is an accomplished engineer, an international person, a consultant, and going to have a nice time. So I want to look at that. So February 13, 2026, Friday like this, now within Ena Ofugara, managers Ventures Limited in the US. And the big one, our teacher, Professor Oluleye, will be retiring this year, specifically 18th of September 2026. He has put in over 45 years of meritorious service. He has built generations, and produced professors of professors. Yeah, they have built industrial engineering from the scratch for Nigeria. So we have made up our mind to celebrate him and honor him These are heroes who could have left the shores of Nigeria and go and earn, but they decided they decided to stay back in Nigeria and train all of us. So we owe them a lot. We owe him in particular a lot. A role model, gentleman, our teacher. So I want to we started the announcement. It's going to be the honor will be in three component kind of thing. We'll do a valedictory lecture, which will also be a 70th birthday celebration by the grace of God. The lecture will take place in Trenchard Hall. So please, let's put our diary. 18 September, it will be virtual, it will be physical and virtual, but we want to be present physically. Then we'll do a book of readings, a very high quality book of reading. So all of you are academics, irrespective of your background, you should contribute to this book of readings. For those of us in academics, it's an opportunity for us to get publications. And I want to assure you, our department, we have experience in generating book of readings. So it's going to be a very good one. Then don't mind my spelling there. We are going to have a beautiful lab or studio in his honor, so that all these people have decided not to run after money, but to run after building people. They should be honored, and Professor Leye should be honored. So we want to celebrate him, and something of important will be named after him in the department. And hopefully one of you out there, alumni, you can decide to turn into a building. So let's put that in mind. That's what I have for us to announce. Again, I thank everybody. I thank our special guest of honor. I thank our guest of honor. I thank our chairman, a friend of the department. I thank everybody for your presence. Today's lecture has been very interesting. Yeah, thank you. Bless you. Moderator, you can take over.
Okay, sir. All right. We want to thank everyone, but we would like to thank Engineer Ayo Ajetumobi, who is the factory manager from Rekit, who is also on the call to attend. Is a special guest of our guest lecturer. Thank you, Engineer Ayo Ajetumobi, for being on the call. We would like to know you more some other times. Thank you very much.
Well, Engineer Ayo is also an alumnus of the department. It's my classmate.
Great.
So great,
wow.
Great Ajet.
That's
great to see you. I'm glad you are here. Thank you, sir. A gentleman to the call.
Okay, thank you very much, sir. Thank you for that. Well, I would like to meet you in person one of these days. So we want to thank everyone for your time, patience, participation, and of course, we'd like to thank all the departmental staff, the people in charge of the IPA engagement team, Engineer Folabi Osho, Engineer Opadare, who always work tirelessly to make sure these occasions comes to, being and be lively. We thank you all. We also thank everyone, the friends to the department who have participated. Also, we thank the students of the departments, the undergraduates, the graduates, the alumni group, the master students, the MEM, the postgraduates generally. Also, we thank Professor Fadare of the automotive engineering. We thank you all. For every other person that I've not been able to pick, my apologies, please, but know very well that you are all appreciated, and we don't take this love that you always show for granted. Thank you very much. We would like the guest lecturer to give his closing remark. The final remarks from the guest lecturer.
All right. Thank you very much, Dr. Adebinkwe. So once again, I think it's my privilege to be here and also to thank my lecturers in person and also my able factory manager at Rekit. And just like Prof said, the moment I got into Rekit, I just went to his office. I was like, sir, you don't know me, but me, I know you. We are from the same department, and that's how he was able to bring me under his tutelage. Dr. Engineer Ayo Adetumobi, I'm forever grateful. So once again, it's been quite nice, and I thank everyone for making their time out to be here on the 40th alumni lecture series, whereby we've tried to demystify the concept of integrated work system and how integrated work system is responsible for a zero loss and high performance manufacturing industry. And also to let you know that you can connect with me on LinkedIn if you have any specific question or how you can personally implement IWS, whether you work in the industries or you can even be in the department. So, and I'm also open to, taking this to a much larger audience, even having some paper presentation on this concept, which I think has now formed the bedrock and the basis of everything that I do. So my sincere appreciation to the guest of honor and also to the special guest of honor, the chairman of the occasion and our able host, Professor Oladokun. Thank you, everyone, and do have a wonderful night rest.
Thank you very much. Thank you very much. We call on Dr. Mojisola Bolarinwa, our former head of department, for vote of thanks. Dr. Mojisola Bolarinwa to give vote of thanks. Kindly unmute yourself, ma'am.
I want to, on behalf of the Industrial Production Engineering Alumni Association, sincerely appreciate our guest speaker, who also is an alumnus of our department, for the well-delivered and inspiring lecture. Engineer Shini Oladejo, well done. Please keep the flag flying. I say a big thank you to the chairman, Engineer Yomi Oyerinde, for taking your time to declare the lecture open, and not only declare you have declared the lecture open, you have also made some further contributions to buttress today's lecture. Thank you, sir. I also like to express our profound gratitude to our special guest of honor and the Vice Chancellor of Chrisland University, Abeokuta, in person of Professor Yeduni Arulogun. Thank you, Ma, for your time. We know it's not easy. The office is sweet. So for even still having time for us tonight to make this 40th lecture a successful one, that we say thank you, Ma. We equally thank Professor Adeni for your presence, for the goodwill message delivered in the course of today's lecture. Thank you, sir. Our versatile, dynamic head of department, Professor V.O. Oladokun, we appreciate you for your unrelentless effort to keep the department forward, always moving forward, ever moving forward, and never backward. Thank you, sir. Our daddy in the house, Professor Oluleye, thank you, sir, for your time. I know normally at this time, academics, they don't take their night rest for granted, but still keeping you awake at this time. Thank you, sir. Professor Fadare, a friend of the department. In fact, not only a friend, you are part of the department now, like the HOD of Automotive Engineering Department. Thank you, sir, for always taking your time to be with us. On the IPA engagement team, our able MC, Dr. Adebinkwe, thank you. We know, despite the proxy, you still created the time to be with us, and you really added color to today's lecture, colors and flavor to today's lecture. Thank you. Dr. Skolawole Adeyeye, Adem, and a host of others. I thank you for always working together as a team. And that's why supporting our HOD and everybody working together. I say thank you all. Engineer Seun Opadare, yes, thumbs up for you. Thank you for always being there for the department, as well as all other participants, members of the IPAA, who have all contributed to making this 40th lecture a huge success. I say a big thank you to everyone and urge us all to continue to keep the flag flying as we remain loyal ambassadors of this great department. Thank you all. Happy night rest and see you again next month. Bye.
Bye.
MC, sir.
So,
Thank you.